Ngalakin Khadijan Nyunga Boja.
Recording in progress.
Okay folks, I think we should probably start. Thank you all for coming today. I know a lot of people have midterms, etc. this week. I'm hoping to cover some pretty important material today. This is lecture 7, so it's week 7. For the next 2 weeks, we've got various key activities for this unit. We have assessments this week in the pre-review design presentation, and next week we have the design review meeting. The design presentation is essentially your opportunity to show the facilitator what you've done within the technical aspects of your design. Right? Key mistake a lot of people make in these presentations is to come up and say, I did I ran these meetings, I did this project management, I did that project management. That's not what this meeting, these presentations are about. They're about the technical aspects of your design, how far you've got with that. Now, if it's okay to talk about your requirements, it's okay to say, I contributed to these requirements. But in that process, you need to show how you contributed to the design aspects of, or the aspects of your design that satisfy those requirements. So just be wary how you present things this week in these presentations. They are roughly 5 minutes. Sometimes facilitators allow you up to 6. And then you basically have some questions from your facilitator and need to be able to answer those questions. The key thing when it comes to both these aspects is you need to understand your design. Particularly when it comes to next week, the design review meeting, there needs to be an understanding by everybody on the overall design that has been achieved. Thanks, Adrian. Okay. How do I get me on this? That's better. I can see myself. Beautiful. Right. Next week, design review meeting. There is an implicit statement there that you have some level of design to review. And by this point, I'm hoping, as I've been telling the students in my weekly meetings, that you do need to continue your technical design aspects as you follow along this unit. Right? So next week you'll be presenting that to a facilitator. We will be rotating around the facilitators. At least we'll be trying very hard to rotate around the supervisors. So the person who attends your design review meeting is not your supervisor. It will be somebody else. And the concept there is it is somebody who has not had any input to your design whatsoever. And so they are a fresh pair of eyes. The point of the design review meeting is not to catch you out and say, hey, you did a bad design. The point of a design review meeting is to catch the mistakes before they propagate too far and give you a bad design and a bad product. Right? So I'll be presenting more stuff about that in this meeting, in this lecture. So in terms of what you need to present, somebody in your team needs to get up and present at the beginning of that design review meeting, a clear picture of what is trying to be achieved, what your requirements are, and how your design stands at present. Okay? And then hopefully the person who's sitting there will pick it to bits, and that's what you want, right? Now remember, the assessment for this is this is the team meeting. There is no additional design review meeting assessment. It is just assessed within your team meeting. Right? There is no marks additional for this. But the point of the design review meeting is to make sure you figure out as much as you can that's wrong about it, and that helps you refine your design. Okay, overview of a design review. It's an essential part of any design process and can happen multiple times or be an ongoing process during a good design process. Some companies have various design review stages, and the funds for each successive stage are contingent on approval by somebody that that design is sound. So it's not just you that goes through this meeting. Somebody has to sit there and say, okay, I'll put my name to this design, and I'm happy to say that the design these people have come up with is sound. Generally, the way we do it here is it's an independent reviewer. That's what we're trying to do. Have an independent supervisor come and attend, and they assess suitability, adequacy, effectiveness of what you present. And the team will defend your design. So be ready to go up there and say, when someone picks a fault, be ready to say, no, you're wrong. Right? My design is right because of this reason. So don't just give in to somebody saying there's a fault with your design. They may not have seen it completely. Right? There should be constructive arguments in this meeting. Right? And don't go over there thinking this is an exam. Right? They're not there to fail you. They're there to find the faults that exist in your design, and that's how it should be. And no one comes up with a completely perfect, flawless design first time. All right. Generally, this is a design process. Not everyone follows this design process. This is sort of like what we're trying to do. You identify the user's needs. You develop a set of design inputs. That's your requirements. These notes are already up. You don't need to take photos. They're on LMS. You go through the design process. You come up with some design outputs. And then at the next stage, you come out, the product or service that you're trying to produce comes out. And at each step, there is generally a design review process. Now, the requirements analysis that you already did, the discussions you had within your meetings with each other and with your facilitators regarding your requirements, that was sort of a design review for your requirements analysis, right? Now we're going through the design review for your formal design and at least a first order review of what your design outputs will be like. And generally in this kind of process you've got a verification which looks at your design outputs and asks, do my design outputs match what my design inputs require? So, am I achieving my requirements? That's different to the validation, which is basically looking at the product or service you come up with and say, do I meet the customer's needs? That's a different one. So, verification and validation, they're tied together, but they're not identical, right? So, just be careful there. So verification is more about process. Validation is, did I get it right in the end? And generally, these are the sort of things that you will be reviewing in each design process. Have the right methodologies been used? Were my initial assumptions and inputs correct? What assessment criteria will be used? What did my documentation look like? Did I follow the right procedures there? Design decisions. What design decisions have I made? Now, something as engineers we're afraid to do is make wrong decisions. And we have to get away from that mindset or you will never come up with a design. Right? Sometimes it's really good to come up with a decision. Right? Make a decision, move forward, find it's wrong, and then make the correct decision afterwards. Right? This is an iterative process. There's nothing wrong with wrong decisions. The word wrong is bad. Bad is wrong. So when you're going forward with these designs, take the step of making the decision. I could be wrong, I could be right. Sometimes it's almost a guess, an educated guess, but almost a guess sometimes. But you need to be able to make those decisions and then move forward. There are also standards which provide guidance on design reviews. Now, the Australian standards are mostly available to us through the UWA library, so if you wanted to look that up on the UWA library, you'd be able to find it. And then there are ISO international standards which also deal with similar things. Okay, I'm going to go over an example here. What's been asked here, what's been asked here is to design a gate, right? And this shows you, I'm just going to see if there are any questions. No questions so far. This shows you who the various stakeholders are, what type of gate we're trying to build. This is a double gate, each with 10.7 meter width, 2.5 meter height. Each weighs 1.3 tons. Pretty heavy. Now, if you have your laptops, go onto LMS and dig up that meeting minutes template. I've got it here, but it'll be useful to sort of, you can actually enter things as we go. Give people a couple of minutes. All right, so I'm hoping people have that up. So that's what it looks like. The text is a little bit small on here. Hope people can see it. Having the document in front of you makes life a little bit easier because of the resolution of this screen. All right, now this is the template you'll be using during your design review meetings. All right, and you'll be going through this step by step, analyzing your design. So, going back to our example, it says specification of the gate provided by Hannah Civil Engineering to a company called Leja or Leha. Contractor shall provide 2 sets of 10 meter opening and 1 set of 18 meter opening gates, bottom angles for tracks, portal frames and U-bolts, supply and fit carry running wheels, and vertical support wheels, guides on portal frames, unload and erect on bottom racks, and HD bolts provided by the contractor. HD bolts, I think, mean high density bolts. Don't worry about it. All the details, all to be detailed in the architectural and structural drawings and specifications. In addition, designers basically prepare fabrication drawings for the gates and supplied, delivered, partly installed the gate steelwork. So a company called SDA was also contracted by one of the original contracting companies. Now there's a little bit of a confusion here on who's been contracting whom, and you'll see the consequences of that later when I go through the case study. But let's try, as a group, trying to go over this template. So, project objectives. Now, it's pretty vague what's defined in those documents that are provided. And basically the contractor can make up their mind. They'll go through a requirements process, you would have hoped, and come up with some set of requirements that the client agrees to. This doesn't look anywhere near as good as it should. Now, I read out what we've got, and that's all pretty clear to all of you, right? What they're trying to achieve. So that's basically what you note down for 3.1 here. 3.2, design inputs. Does the proposed design address each requirement? We don't know at this stage. What are the design inputs? Have all inputs been identified? Have implicit requirements as well as explicit requirements been identified? Have national and international code standards and legislation been identified? Have any conflicts between code standards and project requirements been identified? Do any of the conflicts, particularly safety, need to be resolved? So these are things we'll see in the case study as we go. But there are a whole bunch of regulatory requirements for this gate that you'll see weren't properly followed when the process went through. But, for example, let's look at the project we're all doing at the moment. I think we've raised this before. Can someone name a regulatory code that you've come up across yet? You should have by now. Adrian's been raising this a few times. Anybody? Come on. It's okay to say something wrong. Yes?
Software legalities, so you need implied consent in order to track people.
Perfect. Right? You can't take logs of what people are doing without them agreeing to it. So if I am going to swap my card and log into this and have the fact that I logged into it recorded for whoever knows how long, then I need to agree to that. Now, you can put a condition on that I can't get access to the equipment if I don't agree to it, but that's a different story. People need to have agreed to that. Similarly, electrical safety, a whole number of standards associated with that, who can do wiring, all that kind of stuff. And then the next aspect is, as we said, safety. Now, can somebody come up with a few safety aspects regarding this gate? Anybody? I need a list of names and faces so I can... Adrian's team tool needs to be expanded to the entire lecture, I think. Anybody? Come on. Fireproof? Potentially, yep. What else? There's something glaringly obviously, if you look at that original thing. Yes? When they come together, what happens if someone standing in the middle? Right? There's another one. Anybody? It's relating to this. Exactly right. That's a very heavy gate. For every meter of length, that weighs 134 kilos. It's really heavy. Right? So if this falls down on somebody, chances are it's going to kill them. Unless they're exceedingly lucky. So you can come up with others. Electrical safety, it's got to be driven by something. How's it powered? How is that isolated? Then come human factors. How is this going to be used? Anybody tell me a human factor affecting this design? Something that you didn't see in that original blurb that I read out, right? What about the usage factors need to be considered?
Some way of easily opening and closing it.
Yes. What else? Keep going. Okay, we've got a remote. What happens if you lose the remote? Yeah, that's a good one. Yep. Keep going. More. There's a really fundamental one.
Get locked inside.
What's that?
Will get locked inside
For what reason?
because they've lost the remote and the remote is broken.
Okay, there we've got something, right? What happens if we lose power? Right? That's a heavy gate. How am I going to open it? Right? So all these things need to be considered when you're using. So when it comes to your design reviews, these are the sort of things, come up with it's not just the supervisor, external facilitator who's sitting there. Throw your own questions at the design. This is the only way you end up with a good design. Hammer it to bits, and what survives will hopefully be good. Reliability. Now, how often is it supposed to be unavailable? Or how often can we afford it to be unavailable? Right. If power goes, if we lose power in the system, in the power grid, once every 6 months, and there's an evacuation event, how do people get out? En masse. Right? So reliability is a key factor that you need to consider. Maintainability. How often do I need to service it? What do I need to do to service it? Environmental aspects. Anybody? What environmental aspects can you think of? No. Well, that's a good one. That's a good one. Noise. Is this going to be really noisy and affect the noise pollution around the area? Maybe there's a lab right next door that really can't stand lots of vibrations. Power consumption. The other aspect of environmental effects is lifetime. So at the end of its life, how's it disposed? Does it just go and get dumped into landfill? A lot of countries are now requiring manufacturers to plan for the entire life of a product they put out, rather than just, here, it's your problem after I sell it to you. Okay, there comes life cycle. Costs. So we're dealing with manufacture costs as well, but operating costs. What other factors could impact the cost of the design? Right? Then comes legal approvals. That sort of touches on one of the earlier ones that we talked about. What regulatory approval is required. Sometimes it's national, sometimes it's state, sometimes it's local government, all provide individual regulatory frameworks, and you need to be up to speed on all of them. And then 311 is your list of action items at the end of your meeting, and they need to be documented. So you come up with an error in the interface of your card reader with microcontroller. One was using I2C, the other one was talking USB, and someone wired the two together. Right? You assign that action to somebody, You give them a due date and you track it. So on the day that it's allocated, it's yet to start, basically, right? And that's how you manage that process. So beyond there may be a secondary review to go through, see what changes have been made, how do they stand up to a review. We don't have the time to go through that, we only go through one. But generally there are more than one review. And other considerations, anything else you can think of. All right, let's look at the case study. I want you to pull up on LMS that particular document, if you can see it. All right. So this is called the Melissa Maybury case study. It is actually a case study that's provided by Safe Work Australia as to basically how not to do a design. Well, more like what things can go wrong and what you need to be wary of. Can you read that? Barely. So basically it's talking about a 28-year-old young lady who came to pick up a friend from the place these gates are being deployed. When the friend came out to leave, he couldn't open the gates automatically, and so what he did was he disengaged the motor and he moved it manually. Not exactly sure how this happened, but the young lady was standing next to, looks like she was standing next to the gate. The gate actually came off the rollers, and a 1.3 ton block of metal fell on her, and she died as a consequence. Generally there is legal proceedings after something like this. Consequence was Simpson Design Associates, or SDA, the gate designer, was fined $185,000. High Tech Industries, the plant operator, was fined $135 for breaching various parts of the Act. Lehar, the gate manufacturer, was fined $155,000 for breaching their relevant components of the Act. Two of these entities pleaded guilty afterwards, or towards the end of it. SDA appealed. However, the appeal was dismissed by the full branch of the Industrial Court of New South Wales. So, fatal incident in 2003, legal proceedings finished in 2011. Right, so 8 years of pain for the family and friends of the person who died, as well as the companies involved. It's financial, legal pain, and you don't want to go through that. You'd rather avoid that. Interesting why. So, something that was never specified in all the design, well, in the design brief in this process was the need for manual operation. The brief was to provide a steel bifold gate system that could be opened and closed via digital keypads adjacent to the gate or overridden from the control room. So the control room could basically open and close if required. So this part basically is essentially saying it was very unclear as to who was doing what, whose responsibility it was for various aspects of the project. So who was subcontracting who was not clear, not even clear to the coroner. And that's a very bad state to be in. Right? When you're doing this design, responsibilities have to be very clearly delineated, and so in your design process that needs to come out. Who is responsible for what aspect of the design? Why can't I see the rest of it? Okay. Give me a second. With respect to the competence in relation to the gate design and construction, the coroner states, it is relevant to note that neither LEHA or SDA had any previous experience in gate construction or design and are not aware of any particular industry practices in relation to stops. So basically, if that gate had a stop to prevent it coming off its wheel, going too far and coming off its wheels, it would not have toppled on someone. There's generally a stop on the top to protect it from that. It's only if it comes out of that that it falls, right? So it's pretty much common sense. If you have something like this coming out, that you would have a stop. But it comes down to competence here. Remember in the PPIR how we're talking about, do we have competence to act? And if the answer is no, we need to get somebody in who has competence to act. And again, this needs to come out in your design process. If you do not have somebody with the competence to act in a certain aspect, how do they either upskill to develop that, or who do we bring in to provide that competence? We should not be doing things that is completely foreign to us in a design. When the plant was commissioned around December 2002, there had been problems with the electronic functioning of the gates, and most frequently the Western Gate. Coroner noted, it would appear that the usual way for the gate to be opened and closed when the motor was not working was to disengage the clutch and move the gates manually, although I note the observation from TNT opposite that a vehicle with a rope and a front-end loader had been used on 2 occasions. People couldn't move it with their hands, and so basically tied a vehicle to it and pulled it to open the gate. That's how bad the design was. High-tech employees who operated the gates manually had closed the eastern leaf first. So only one of the leaves had actually come off. The coroner concluded that it was not because they knew that the welded stop on the eastern leaf was secure. So they had randomly used the eastern leaf a few times and it had been okay because there was a welded stop, which looks like the stop was unintentional. The result was that the western leaf was always closed against the eastern leaf and therefore did not travel past its midpoint until this one time. The manual gate closing operation had a sequence critical fault that came into play on October 2003. Marks on the western portal indicate that the stop on the western leaf had been out of position prior to that. failure of the electronic system was not infrequent, and most frequently the system for the Western Gate. So it was quite common for the Western Gate to be non-functional.
So just to go,
Yeah.
what is that? There was a stop just there.
The stop was on the Eastern Gate.
You said that one on the Western Gate.
Stop on the Western Gate had been out of position.
Yeah.
So maybe it was no longer there.
Right.
So someone tried to... The whole thing is very blurry. Read the case study and you'll see how blurry it is. It is like... it looks like not even the coroner could understand completely what had happened, because the various parties really didn't know what was going on. Okay. In relation to the failure of the closing system, the coroner noted the leaves of the Western Gates are massive. They were not designed to be moved manually. After the first time the electronic system failed, Hi-Tech should have undertaken a risk assessment to ascertain the best backup system for a work safety perspective. Moreover, knowing that the safe manual operations of the gate depend on the adequacy of stops to hold the leaves within the portals, Hi-Tech should have inspected the gate stops on a regular basis. Yes, you're right, Adrian, there were stops. Lugs could have placed on the track as additional measure. So it looks like there were stops in place, and because of the weight of the gates, they'd just been wedged off, knocked off. Exact parameters of the contractual responsibilities of the various parties has been the subject of some debate. Right, so you don't want to get to that state in your design. He was supposed to do it. She was supposed to do it. No, those guys were supposed to do it.
I think that what I learned is that the more people who are involved, the more money there is to be had.
Yes.
When you go and sue them, because you sue everyone who's on there.
So it's curious. It doesn't say that money was actually paid to the victim or the person who died or their family, right? So they were just fined by the state. And plus, yeah, you don't want to give your life to earn a few $100,000. The previous accident with the gates occurred 12 November 2002, which drew the attention of project managers to the manual opening possibility. It also pointed to the absence and the importance of the stops. Okay, now here again it says absence of stops. In this incident, the leaf of one of the 10-metre gates fell while an employee of Magic Door Industries was installing the motor. So that person survived, didn't get crushed. MDI refused to complete the work installation on the site until stops were affixed. Oh, okay, so there weren't. MDI required them. Temporary metal stops on the western portal was bolted in place with a single bolt and had swiveled out of position. This had been put in place in November 2002. Now the investigation following the incident and subsequent court proceedings, the identity of the party responsible for temporary bolted stop was not determined. So they don't know who actually put those temporary bolt stops in place. Again, he did, she did. None of the stops of the other gates were considered to be appropriately designed but worked because they had been welded in place rather than bolted. During the inquest, the coroner visited the premises and was surprised to find the Western Gate could not be operated electronically on that occasion. So the day the coroner turned up, it did not work. They received a structural certificate from an engineer certifying that the rectification work had been completed. Additionally, the motor on the western gate had been reinstalled and the gates recommissioned on March 2006. Work cover carried out an inspection on the following day. Yep. So basically what it comes down to is there were key design decisions that were omitted in the process. Right. So the right questions had not been asked, and it looks like a incomplete design process had been followed. So these are the lessons learnt. Small jobs do not necessarily equate to low risk. So this wasn't a big job. It would have been a couple of tens of thousands. And the OH&S obligations are no less stringent on small jobs. Competence to act is very, very important. As I said before, we need to make sure the people doing the design have the competence. Looking outside your narrow view of what you understand. So you need to talk to other people, you need to brainstorm within the team, and see what else could go wrong. What could go wrong is a real important thing we need to look at. Project managers need to take control and ensure effective coordination of designers, suppliers, Incident shows how important it is to get all parties together for safety and design considerations. Right, so that's part of your design review. Right, safety in design. So if you come up with a design which somebody can easily electrocute themselves, well, that's not ideal. I'll skip that for the moment. Conversely, when a company was engaged with only a limited role of design, the designers need to be proactive in being involved in the wider OH&S. So when you're asked to install a motor, if all you do is install the motor and not care about anything else, then you're essentially being somewhat negligent. And same thing, the gate. If you don't consider as many possible use cases as you can think of, then you're being potentially negligent. The process of engaging sub-consultants need to ensure that sub-consultants are part of the safety and design consideration. Companies need to ensure meaning issued for construction is clearly understood by all parties, and that understanding is consistent with contractual obligations. So if you put a stamp issued for construction on your design, that's basically saying your company puts its name to it and stands by it and takes responsibility for it. It doesn't mean go ahead and build it, we don't care what happens after that, it's no longer our job, no problem. In this incident, the project manager was not charged with the breach of the OH&S Act, despite having operational control of the site during construction of the plant. No doubt the various WorkSafe authorities will review the comments made during the prosecution of SDA and the subsequent appeal, and perhaps take a different approach in any subsequent incident. So basically the project manager got away without individual fines. Now, also realize this was a 2002 incident, 2003 incident. The WorkSafe regulations have changed a lot since then. About 5 years ago, big changes came in, which basically put responsibility squarely on everybody. So it's, if this lecture theatre isn't safe, and that, as Conrad was talking about, one of those projectors falls on that young fellow's head, right? If I had seen that as being potentially unsafe and not reported it, then I am liable personally, not just as an employee of the university. Right? To me, that looks safe. But the responsibilities of these sort of things now lie on individuals on top of just the organisation. Right. I think that's pretty much everything I have. How am I for time? Okay. Pretty good. Any questions? Any questions online?
There's a question.
Yep.
Wondering when you're discussing sort of the end of the life cycle, so decommissioning, things like that.
Yep.
Do you need to present that for sort of every element you present in your design?
For this one,
Yes.
for a preliminary design review, I would not consider that.
Okay.
Right? So don't worry too much about extensive life cycle aspects. A consideration of it is important because it's in the template, right? But I wouldn't expect you to say, okay, this is going to be decommissioned in this way, using these steps. Such and such is going to take responsibility for recycling of the components. You don't know what components are going to be in there at this stage, right? So a general discussion is what you would be expected to conduct during that time. Anyone else? So does everybody understand what's expected of you in the next 2 weeks? Yes? So this week and next week in terms of your design presentations as well as the design reviews. People understand what is... Okay, I'm seeing a few nods, no shakes of the head, so that's good.
I don't know what's expected for the rest of your life.
I don't know what's expected of the rest of it.
When I was a student, the example, they never did detailed case studies like this when I was a student. And the only example we have got was a lawyer coming in and saying, you're a party and someone says, oh, my fuses keep blowing, and your response as an electrical engineer is, just get another rusty nail and throw that in there. That'll fix the fuses from blowing. The house burns down, you're responsible. That was the extent of our training 30 odd years ago. So we've come a long way to the things you need to consider.
So Adrian, as a youngster, I spent a few years in Sri Lanka, and we used to actually do that.
Yeah, the worst case is where someone asks you advice when possibly you're a little bit inebriated, right? And everyone's willing to give free advice when they're a little bit drunk. Oh yeah, you can do that, right? But they don't see you as drunk; they see you as a professional, right? If you were a doctor and someone said, "Oh, I've got a terrible bad back," and they said, if they were drunk and said, "Oh, just jump up and down, jump off a roof."
Try some bungee jumping. Try some bungee jumping. It'll straighten out the back and fix all of them.
Right? Then, that doctor wouldn't be responsible. You'd be responsible. So you're always on. You're not seen as a drunken person at a party. You're seen as an engineer, right? Who's being asked for advice. So always make sure that you have a hat on that says I'm professional, because you.
Or something that says, I'm drunk, don't ask me technical questions.
Yeah.